Let's get started. Good morning, everyone. There are still 3 seats available in the front row. Welcome. Thank you very much for being here. My name is Jean-Laurent Philippe. A lot of people call me JLP because it's easier to pronounce in other languages, and I'm the CTO for Intel EMEA. CTOT for technology, and we are going to talk about technology. I asked my colleagues here to give me a warning in terms of time because I never stop if we talk about technology. So let's get started. I'm going to talk about the goodness of the Intel Xeon 6 processors that are integrated in marvelous systems from HPE in the ProLiant Gen12 family of products. And what is interesting is, of course, all of the technology that goes inside that the products from Intel and HPE have been developed with. But what's interesting is what they make possible. And we are going to talk about that. Are we taking questions during? Okay, so just shout at me and I'll take questions. Okay, technology works. Okay, great. You've been exposed and you've been using Xeon processors for a lot of years, actually decades, because I worked on the first one, which was called Intel Pentium 2 Xeon in, I would say, 1998 or something like that. And since then, we've improved on all of what we put inside the processors. And then what we put inside the processors, HPE takes it and improves on it and makes it usable. What we are seeing now is that there are a lot of Xeons in the data centers, and they are used for running an extremely wide set of applications, workloads. But what we see is that the requirements and the needs are evolving. Of course, everybody is talking about AI because AI is something which is added to the workloads. It's new tasks, it's new environments, it's new software. Yet, you don't want to just have a data center that runs AI purely, because you want to still do everything else that is helping you be successful. So you still need to run everything that you had before, plus new things. And the requirements are just increasing. You need more throughput, you need lower latency, you need more security, you need efficiency, cost of energy is increasing, you want to lower your TCO, you want to contribute to a better sustainability with limiting the carbon footprint that your solution is bringing. And all of this, you rely on Intel for the CPUs and some other ingredients, some systems from HPE, and HPE plus Intel work extremely closely together to get the ecosystem, the software ecosystem, ready for any new platform. It's not by luck that you're sure that from one generation to the next one, you can take your existing environment with applications and it will run. There are decades of software ecosystem enabling that has been made by Intel. We have thousands of engineers doing software, although we are considered a hardware company. And that's the software compatibility that makes your solution extremely attractive and needed. Let's get into the areas that are important. We are going to talk about what features the ProLiant Gen12 with Intel Xeon 6 bring: security, performance and optimization, and automation and AI. If there's one slide that you need to get away with from today, it's this one: 5 reasons for choosing the Intel Xeon 6 processors with the silicon-enhanced security. Security is important. In the previous hour, there was a panel next door that was about data, AI, APIs, all of those things. And there was something interesting that was said, which is there are data centers and there are centers of data, but the data is always at the center of everything that we do. And the data carries some IP, some value for you, but also for your competitors. So it has to be very, very seriously secured. Secured at rest, secured in transit, secured when being processed. At rest, we know how to do it. It's been going on for some time. Yet, there's one thing that you need to remember. It is that the data which is encrypted at rest at the moment, if some people put their hands on it, and you have not encrypted it with post-quantum technology, then they will be able to decrypt it later. So even the data that you encrypt today should be encrypted with post-quantum encryption technologies. Same thing for in transit. But then the biggest problem is really when you compute the data. They will be decrypted anyway. So that's where the technology for guaranteeing this comes into play. 10 years ago, we came out with a technology called SGX, Safeguard Extension. I'll talk about it in a second. I won't go into details now. About 4 or 5 years ago, we came out with a technology called TDX, Trusted Domain Extensions. And this one is easier to use. I'll talk about it also, but these technologies encrypt the data, and when they decrypt it in an enclave of the memory which is not readable even by a super user. Or if it is readable by a super user, they don't have the key to decrypt it, so that's the good thing, and that's the encryption for confidential AI and confidential computing. Confidential AI being, for me, a subset of confidential computing. Then you might want to do that as effective as possible in terms of encrypting and decrypting, compressing and decompressing. And number 3 here, the efficient data handling, is using some ASIC inside the processor, which is called Quick Assist technology, that does this in hardware extremely efficiently. I talked already about the quantum resistant encryption that you have to look at. And then we also put in our product solutions for more resilience. What is important is that security is not a taboo at all at Intel. We have teams working on it and trying to break what we do. We work with ISVs, researchers, universities, everyone who wants to contribute and who will say, hey, we think that we have found something problematic. Can we look into that? We are always open to doing that, and that's why we release on an extremely regular basis some warnings about, hey, we've seen that, and here's how to work with it and how we are solving this issue. Here, it's extremely clear. We are open, we communicate about it, and we fix our problems. It says at the bottom, 96% of the vulnerabilities disclosed in 2024 were proactively released by Intel and with a solution. And this is coming not from an Intel analysis, it's coming from ABI Research, which is a third party which is not affiliated with Intel. So something which is very clear that security We work on it, we implement it, we talk about it, we communicate. Security is important. I was saying that 10 years ago, we came out with a solution that is called SGX, that's the one that you have on your left. And as you can see, it is the minimum imprint that you can have in terms of minimizing the amount of data, including the data itself, but also executable or anything like that, that needs to be encrypted and decrypted in an enclave. It is marvelous as a technology, though it has a small issue, which is you have to change a little bit of your software and your application to take advantage of it. No way. That's not something that anyone wants to do. You don't want to have a version of your application and software for SGX, another one for something which is not SGX, or another one which is for something else. So we decided to look at it from the perspective of what do people work with mostly? They work with VMs. So we created, instead of an application isolation solution through hardware technology with SGX, to a VM isolation solution with hardware technology with TDX, which is trusted domain extensions, and those are instructions. In this case, it takes the whole VM, it puts it encrypted into a memory enclave, and it's only in that memory enclave that it will be decrypted, and that only this unique part will be accessible for the application itself. So it won't be visible by anyone else. In my team, I have two experts of security. One of them did something pretty interesting. Assume that you trust your employees and that your system administrators, they all have root access, and they can therefore do memory dumps. You can do memory dumps of a VM, of everything, anything, and then you can do some grep in it and find some information. We tested it. In some cases, you might have a policy that does not allow memory dumps, but it's not in place everywhere. Assume that you have nothing like that, and anybody who is sudo or root can do that, can do a memory dump. Then you do a grep, you find the information. We just did it on a VM that was running as a continuous banking solution for validating credit card transactions. In this, you have decrypted the credit card numbers, the CVV, and everything. Then we did exactly the same in a machine which is TDX enabled. Nothing to change, you just run the same thing. The root person can still do the memory dump, but then it's all encrypted, non-visible, and it costs virtually nothing. We did the analysis between 0.5% and 1.5% in average of performance impact by using this. So if banking, health for the client information, government entities look into this and say, wow, I need my data to be secured as often and as deeply as possible, then you or your customers as enterprise also need to look into that. And this technology is available now, has been available for some time, but is available now and very well implemented by HPE. Great. So what about when you do AI with your GPUs? Ah, man. It's not running in the CPU memory. Therefore, how do we do that? TDX Connect is coming and will be solving that issue. Actually, it exists, and we are working with NVIDIA to make it available. So on the left, you have the trusted execution domain, which is covered and protected by TDX. And TDX Connect will carry that security over to the GPU for whatever you want to do in the GPU, inference, training, having models, or everything like that. So look out for this, it's coming, and it is solving the problem of not only confidential computing at large, but confidential AI with, at the moment, some NVIDIA GPUs, and we will be expanding that to others. So we are showing that Xeon has been running very wide varieties of applications in the past, like your SAP, your printers, your Oracle, your HPC, your AI, all of this, your simulations. And that's something that we keep on supporting, and we expand it. We have a full line of products called Intel Xeon 6. I'll come to that in a moment. You will be able to see some in some systems upstairs on the HP booth, on the Intel booth. What is super interesting is that there are now different features available and capabilities so that you can choose a little bit better for what you will need. Some with high performance cores, some with more efficient cores. We'll come to that in a second. And still the goodness of the Intel Ethernet controllers and adapters. I already talked about that. All of the line of solutions that you will want to run will keep on running very well on Xeon. And when it comes to AI, that's the very important thing. This Xeon 6 family of products is the third generation of Xeon products that includes AI instructions. And that's why they are so good at running inference. We'll talk about it in a moment. But remember that they are based on instructions under a code name which is AMX, which is the matrix multiplication, advanced matrix extensions. You're probably very familiar with the AVX, AVX2, AVX512, AVX10, which is coming, which is advanced vector extensions that are available through compilers, and you need to do a little bit of work to get access to this level of performance. With AMX, it's different. We know how AI works. How do you use AI? Usually through frameworks and solutions that you're not writing at the compiler level, but with something that already exists. So what we have done is we have developed the libraries that are needed to do those matrix multiplications on Int8, on FP16, on FP8, on stuff like that. And then we have upstreamed them into PyTorch, TensorFlow, so that when you use the latest generation of these products, then clearly you have access to the version that is optimized to run on Xeon 6. So we are making it extremely easy for you. I'm going to talk about 3 or even nearly 4 types of Xeon 6 processors. The Xeon 6 processors with 12 memory channels and P-core, the performance core, the one that you've been using for the last decades. I'll talk about the Xeon 6 6700 and 6500, which is only with 8 memory channels. That is a continuation of what you have in the 2-socket line of products. And those are with P-cores, and then the 6700E with efficient cores, which is a new line of product, and then the single socket Xeon 6. So let's get started, and stop me each time you have some questions. So the picture that you see here is not a made-up picture by AI. It's a real one. This is a Xeon 6 6900 and I'm going to pass it around. It already fell down, so it's not working, so don't be sorry if you touch it. It won't work anyway. You will see in the middle that there are 3 tiles, each of them with the compute cores and the accelerators that are integrated, like DLB, DSA, Quad, AMX, etc. There will be no quiz about that. I won't go into it. If you want to know more about them, come to me or come to our booth. We have some experts. At both ends, you have the I/O tiles, and that's how we are creating this flexibility in creating different versions. This one you will see on the booth. It has the usual integrated heat spreader on it, but when you want to see something like that, you have to take it from our line of products. This is made in Intel 3, so 3 nanometer technology in Ireland, in the EU. So when everybody claims everything is made mostly in Taiwan or those areas, not at all. Intel 4 nanometer, Intel 3 nanometer run in Ireland. This is 110 billion transistors and a little bit over 7,000 connectors at the back. So hold to your breath, because that's something that you won't see very often. They are getting more and more complex to design, but more and more exciting for you to use. Why? Because they are now increasing the number of features that they have from generation to generation. On this one, we have memory that runs normally with DDR5 at 6400 megatransfer per second. But I'll talk in a second about the new technology, which is JEDEC standard, called MRDIMMs, that allows it to run at 8800 megatransfer per second. And you will see that for memory bandwidth bound applications, it really makes a huge difference. Everybody wanted to do HBM. Yeah, it works, but it's costly. It's hot, so it takes power. And then all of the power that you get from the HBM on the package, you can't use it for doing the compute. So that's not something that we plan on doing on CPUs anymore. The 5th generation of processors, Intel Xeon 5th generation, codenamed Emerald Rapids, was up to 64 cores. This one is up to 128, 2x. By the way, compared to the memory, we are a little bit above 33% in terms of memory bandwidth increase generation to generation. We have 6 UPIs that are used for creating up to 8-way system without any hardware needed in terms of addition, and up to 96 lanes of PCIe Gen 5 or CXL. The cache also has been significantly increased to about half a terabyte, and as I talked a moment ago, it includes the base instruction set for AI, which is AMX. By the way, everybody asks me that question. So you have registers that are usually about 128-bit long. How big are the registers for AMX? They are 8K. They are capable of hosting a 1 kilobyte matrix. So we are not talking about a 3x3 matrix. We are talking about serious matrices, a kilobyte. And we have 8 of them, so you can imagine that indeed the performance can only be stellar. Let's talk about these MRDIMMs, multiplexed rank DIMMs. HBM is great. It offers a superb memory bandwidth. It has a cost. It has some drawbacks. It wears out, if I can say, or the guarantee is about 5 years. And our processors, we guarantee them for more than 5 years. So that was not necessarily a good idea. And HBM, high bandwidth memory, is pretty expensive. So we leave it for the high-end GPU solutions that actually need that. So what do we do to help you break that memory wall that we are going against? There's never enough memory bandwidth compared to the growth of the compute performance. So we worked with the JEDEC standard and we created the MRD multiplexed ranked DIMMs. That's a standard, as I said, it's available from the various memory vendors and it aggregates 2 ranks. So we could theoretically reach 2x the memory bandwidth, so 6400 by 2, but we validated it at something which is reasonable, 8800. And you can see that on stream triad or on HPCG, the conjugate gradient, those are extremely memory intensive applications because stream triad is only doing memory reads. Then you can see that I claimed a moment ago 33% performance increase from 6400 to 8800, and you can do the math. It's nearly there. We can see indeed those 33% on HPC memory bandwidth bound applications and the AI memory bandwidth bound applications. So this is really something that exists and that is available and that you can buy in systems. I'll talk about it, like the XD230 and others. So the, okay. Great transition from one slide to the next one. You can see here that HPE has taken these technologies at heart and has created extremely dense solutions. One new XD230 that can be air-cooled or liquid-cooled. Remember that those processors, the 6900, can go up to 500 watts. So that means you have about a kilowatt max of CPU. You have maybe 100, 150 watts for the memory, maybe 100 watts for the power supply memory, maybe 50 watts for the NIC. You reach easily 1.2, 1.3, 1.4 kilowatts in a 1U, and when you have 42 of them, that means something very decent. So that's great because you have superb compute density available with the XD230 and the 6900 Xeon processor. That will give you for HPC and for AI some very good performance increase from the previous generation or even against our competition AMD EPYC. I really encourage you to come to our booth. Intel is the 1020 and see some of the demos that we are showing. The bottom right one here, Stack 2, which is financial, shows what we have been able to do from the previous generation of Intel Xeon 5th generation processor to the new one and how much it's bringing. Here it's comparing against an NVIDIA A100. So I know that it's not necessarily the latest generation, but it shows the capability that it has, like 1.5x. And from generation to generation, we've been able to show performance increase above 2.1x. So we are serious about not only bringing the transistors, but make them available to run applications super efficiently. For AI, HPE had a generation which is the XD670 with Intel 5th generation, hosting up to 8 NVIDIA H200 GPU cards. And now the new generation, the XD690, is using Intel Xeon 6 processors and can host up to 8 Blackwell ultra slim cards. What is very interesting is that Xeon 6 is the best processor to run AI and the best processor to be the head node to AI GPU cards. That's something that you need to keep in mind. I know that I'm Intel, so I'm preaching for my chapel. But when you talk to NVIDIA and you look at which CPUs they put in their DGX or equivalent, it's Intel Xeon processors. And it was not something that came as a, we love you, we have a partnership, you, NVIDIA, take Xeon. It came before the partnership was announced between NVIDIA and Intel. So it's really serious. They do the analysis and they see that Intel Xeon 6 is the best processor to host their GPUs. So we talked about the 6900, which is the 12-channel up to 128 core processor. Let's talk about the 6700 and 6500 that are still with the P cores, the performance cores, and those are the ones that are usually used for running all of the application in the data center. They are a continuation of the previous lines of processors, still at 350 watts max, so that you guarantee a certain density, but we increase the performance every generation. And again, those with P cores have the same AMX instructions, so what you can run at a larger scale on the 6900P, you can run also on these ones. And they are really optimized for running all of the workloads in the data center for enterprise. Now let's come to the E core. The E core is a core which is slightly different from the P core because it is more efficient. It does not include some of the accelerators like AMX or AVX512. We want it to be much better for anything which is cloud native in an infrastructure. So we have a lot more cores because in this one, up to 350 watts, we can put 144 cores. And it is still a Xeon 6. And we have announced recently the code name, or the brand name, sorry, for the next generation of Xeon with E-core. It will be called Intel Xeon 6 Plus. And from 144 cores, we will increase to 288. So we're again doubling the number of cores. And that, already with this one 6700E, where you can do some marvelous things and get much better performance, and in terms of performance per watt, that's really something that you need to start looking at, because you all want the best TCO for your applications or for your customers' applications. You want to reduce the TCO, you want to pay less in terms of electricity, so that's something that you need to start looking at. It is the best time to look at consolidation, modernization, and refreshing your data center servers. Servers, usually people keep them 4 or 5 years. That was our ideal analysis. Now they tend to keep them maybe 6, 7 years. So when you look at how many new servers of HPE Gen12 will it take to replace servers that were Gen 8 or Gen 9 or Gen 10, have a look and say, oh my God, I will have the same level of performance with one Gen 12 server today compared to 6 of Gen 10 Plus or 26 of Gen 8. This is the level of performance that you will get, and then think pretty rapidly about the total cost of ownership. Much less cost in terms of electricity, software license. We are seeing 84% power saving per year over a period of 4 years when it comes to replacing 26 servers of Gen 8 with a Gen 12. So when we are so critically interested about lowering the TCO, paying less on electricity, this is really something that resonates. But we also know that a dual socket solution might be an overkill. And yet, it's great, but it has potentially not enough PCIe lanes. So we have come up with a solution which is called Rich I/O one-socket solution. It is still a Xeon 6, no problem, same socket, no issue. And in that case, it has 136 lanes of PCIe, which means that you can put a lot more cards into that, yet with all of the goodness of all of the features that the Xeon 6 carries. I know that a vast majority of the servers that are deployed are dual socket. But when you do SAP, Oracle, or stuff like this, you want 4-socket, 8-socket, and Intel still brings to you the capability of designing and then using such solutions without having to go and rely on some type of connections. So 4-socket, fully connected or not, 8-socket, not fully connected, but with 4 UPI, give you that opportunity. Let's talk a little bit about performance, utilization, and cost. What we aim at doing is bringing you the performance, but not at any cost. It has to be reasonable. So on this one, what I'm showing is a Xeon 6 with P cores, shows that if your server is only used at 40%, then you will be able to get a performance per watt which is much better with the Xeon 6 compared to the previous generation, Xeon 5th generation, or with a solution which is latency optimized. So that's something which is very important because you are getting much, much better in terms of performance per watt. And when it comes to how much power is needed across the whole utilization scale, the bottom line shows the Xeon 6 with E-core, so the 6700E with 144 cores, and it shows how much power it is drawing when being used at 20%, 40%, 60%, etc. And that's a dual socket. So it goes up to 660 at the right, which makes sense because it's a 330 watts. And you can see that compared to the previous generation of processors, when you were at 40% or 60% of utilization, you would be using more power for even less performance. So Xeon 6 with E-cores brings more performance at lower power. I think that we are close to Christmas, and that's a good gift that we are bringing to you. So, save power, save money. The 6900 is very good for running high performance and AI applications. So OpenFOAM, CFD, DLRM recommendation. And here what it shows is we compare a 6900 with an AMD EPYC processor, and we are showing a higher level of performance per server, 1.8, 1.4, and we will come to the 6700 in a second, at a lower TCO. Same thing for the web services, image reconstruction on the 6700. 1.5x, 2x performance per server with TCO saving, which are in the range of 40 to 50%. So if with all what I told you today, you're still wondering, do I need to go to my HPE contact and ask them for ProLiant with Gen12 with Xeon 6? I think that you have the answer, because who is going to sit on such savings or such performance that you can have? So I talked about the fact that Xeon 6 is capable to support absolutely every type of workload. And on the AI side, I talked about the fact that it is very good at running AI application itself. I don't have a slide about it, but we have shown that when we compare a reasonable, let's say, between 7 and 20 billion parameter model, and you do inference on a Xeon 6, then compared to an AMD, the Xeon 6 is between 5 and 6x higher performance. And you don't have to update your framework or anything. As I said earlier, you download it, it is ready to take advantage of it. So that's something that is super important. When you want to do POCs, when you want to do inference, maybe you don't need a GPU. Think about the Gen 12 with Xeon 6. And then, when you want to host a certain number of GPUs, it is also extremely efficient. It has superior I/O performance. It has a very high single-threaded performance. It's capable of using MRDIMM, which feeds the core with AI data much faster, and it is ready for deployment. So, best CPU for AI, best CPU for hosting. What are we waiting for? Come to our booth, look at this CPU in action. We have a marvelous demo which shows that, or which shows you how to develop yourself your own RAG solution. Come to our booth, we will explain to you how it works and how it runs extremely well on a Xeon 6. With this, also get more understanding about all of the offers that are coming from HPE, AI optimized, TCO optimized blades, Gen 12 equal Intel Xeon 6. You will get the most out of all of the solutions. HPE brings additional capabilities. They bring all of their knowledge from years and decades of design, software, management, capabilities, different form factors, air-cooled, liquid-cooled, you name it, you have everything that you want now. Come to us, ask for questions, go to HPE, buy servers. That's the right thing to do. Thank you.